This is the last video in the video series covering access control models, and in this video I will discuss risk-based access control model, which is the most dynamic model within all access control models. It calculates the risk score of a access request in real time, and that request or access is allowed if the risk score is under the threshold. So it does not operate on a predefined fixed policy. Rather, this risk thresholds are coded into the policies, and access decisions are made adaptively as per the risk profile of access request. So risk is the combination of likelihood of a bad outcome and impact of that outcome. So if that risk for an access request is under the threshold, then it is allowed. Otherwise, it may be challenged or it may be denied. So there are four factors which are considered while calculating the risk. That is user context, the action severity, resource sensitivity, and risk history. So it is a continuous learning loop in which the outcome of every decision is fed into a risk history to sharpen the future estimate of the same nature. So by using the machine learning, this risk history uh, is being used to make the future decisions. So these risk thresholds are coded into the policies, and it is not up to the discretion of owner or any static label like mandatory access control model. So it is not like a discretionary access control model, and it is therefore a non-discretionary access control model because these risk thresholds are uh, coded in a central manner. So it is not up to the discretion of owner of the object or resource. One example could be if the IP address of a device is trusted one, and these are the working hours, then access is allowed by using simple username and password. However, if the device is unfamiliar and it is operating from a different location, then the system may impose multi-factor authentication or otherwise deny the access. Another example could be the hospital ER staff. Since their risk is low, therefore they are allowed full access, whereas pharmacy is allowed partial access. So it is all decided based upon the context of access request. So if the IP address is from a foreign country, or it is using some anonymized service like Tor or VPN, or if there are simultaneous login attempts from different location, then that risk is over the threshold and access may be denied or multi-factor authentication may be imposed. So it is a real-time response to the threat intelligence. For example, if threat intelligence says that a phishing campaign is going on, then for the duration of that alert, you may implement multi-factor authentication or you may block the IPs which are not trusted. And similarly, if there are multiple failed login attempts to a security information and event management system, then it is also spikes the risk score. So it is very useful in fraud detection cases where there are baseline sets for detecting the fraud, and moreover, per customer pattern, for example, his traveling pattern or his spending pattern, baselines are set. So if these baselines are deviated, then access may not be allowed. So it could be as simple as a binary fail and pass decision on fail and pass of a multi-factor authentication. That is, if multi-factor authentication is failed, then access is not allowed. or it could be as complex as machine learning, where you learn the behavior and make the predictions on the future access request. So if behavior is risky one, then access is not allowed. Now it is a kind of policy decision point and policy enforcement point pattern, uh, which is related to NIST special publication 800-162, which is attribute based access control. However, since that is relevant to more to the attribute based access control, which I have discussed in a separate video in this video series. So some literature places the risk-based access control with regards to reference monitor. So reference monitor is a security concept in which was introduced in 1983 in Orange Book, and Orange Book is also called Trusted Computer System Evaluation Criteria. So reference monitor sits between the object and the subject, and it mediates the access request of a subject to an object. So risk-based access control model is very powerful for a dynamic situation since it is adaptive. But it is complex to build and it is very hard to audit than static models. So it is a right choice if you want real-time adaptive access. For example, if you want to implement multi-factor authentication for if the risk profile increases or crosses some threshold, or maybe in case of fraud detection. However, for a stable and auditable environment, you may want to use attribute based access control, which has a fixed policy based upon the attributes of subjects, objects, and the environment. So risk-based access control model implements the access request based upon its recomputation every time when that access request is hit the system. Moreover, it is different than the role-based access control model because that operates on the roles. So permissions are assigned to roles instead of directly to subjects, and then subjects are made part of that role. But that is different because that is not risk-based. This was all, and this is the end of the series for access control models. Thank you.